My name's Alexander. I'm a senior network and application pen tester at NetSpy. You can find me on Twitter at 0xBadJuju. You can also find me there on Keybase. You can also find our previous work with WMI on the NetSpy blog. And any code you see during the talk today can be found on my GitHub repository. So a quick overview of what we're going to cover. We're going to do a brief background of WMI. We're going to touch on how to obfuscate some fileless backdoors, and then look into how WMI can be used for storage on a target system, which will lead us into creating WMI providers and how to install those WMI providers and alternative methods. The two repositories that will be covered for this are for Power Provider and Where's My Implant. So what is WMI? WMI stands for Windows Management Instrumentation. It's a subsystem within Windows used to manage Windows systems, mostly through data collection. It's been present since Windows 95. Given that it's 22 years old now, it's starting to show its age. Hopefully most people are familiar with some WMI functions. I know personally I used the Win32 process create method a lot for lateral movement. So WMI is very similar to a SQL server. So if you look at the namespaces, you can roughly make that equivalent to a database. A class can be roughly considered to be equivalent to a table. A property will be roughly equivalent to a table row. What comes different is the properties can be either static or dynamic, so data can be dynamically pulled via WMI. So if you do the Win32_process query, you can get running processes which will change over time. A method could be roughly considered to be a stored procedure. And then if you look at the Windows query language, which is how you query via WMI, the select statement is taken from a SQL type statement. So moving on to fileless backdoors. In this we're going to use a method called, or a PowerShell method called invoke WMI duplicate class. WMI has a good implementation of class inheritance. So with the Win32 process class, that inherits from the sim_process class, which inherits from the sim logical element class, which inherits from the sim management element, and so on and so forth. So there's really no reason we can't make a child class of Win32_process that'll inherit all the properties and methods of Win32 process. The two primary ways we can do this is through the derive method and the clone method. A couple days ago I saw Matt Graber tweeted something out about this, and it's a great way to hide things. So in this example, we're going to take the Win32 process class, and we're going to duplicate it into a class called Win32_create. And in this demo, just show a basic example of this. So we're going to connect to a remote machine, and then duplicate the class and put it in there, and then call the create method of the duplicated class. So in the logs, we'll never see a call for Win32_process. That's cool, but it's not a backdoor. The fileless backdoors in WMI primarily come through event filters, event consumers, which is the action that's taken, and then the binding, which takes the trigger and the consumer and pulls them together. Primarily, when it comes to consumers, we see for persistence the command line event consumer, which launches a command line command, and then an active script event consumer, which launches some Visual Basic code. This is a pretty well-known technique. There's a great framework called PowerLurk that came out a couple years ago to automate this. Here's a basic example in PowerShell of how to do this. We have an event filter, which looks for a logon event, a command line event consumer, which launches a PowerShell command, and then the binding for the two. So if we take that duplicate class part, we can duplicate out the command line event consumer pretty simply. And just in this example, we're calling it the derived event consumer. So in case you're alerting, the blue team is alerting on a command line event consumer event, we can hide from that. Event filters are less easy to alert on in logging because there's a lot of legitimate applications that will use an event filter. There's a couple built-in ones related to the Windows event viewer or event log. In this example, we're just, wrong one. I'm going to duplicate out the class for Win32_process. So we're connecting to our remote system, and we've created the derived consumer. Now we're creating the filter for a log on event. Now we're going to create the consumer to consume that event, which is just going to create a text file. And then we're going to put in the binding. Now for this demo, I can't demonstrate that it works, but it works. Now the other thing we're going to cover before we get to the really interesting stuff is using WMI for storage. Now because WMI operates like a database, we can start inserting strings into that. So if we take a file and we base64 encode it, and optionally we can encrypt it as well, we can slice that base64 string into sections. What I've found is that in WMI a string length of about 8,000 fits in pretty well. And then we can insert those sliced strings and then reassemble them on the other side. And we've wrapped this for this demo into a function called invoke WMI upload and invoke WMI remote extract. This demo is a little bit hard to see, but what we're going to do is connect to a remote system and then base64 encode and then upload that file to the remote system. Then we're going to launch a PowerShell command to extract it on the opposite side. So in this instance, we're taking a DLL and extracting it out into the Windows System32 WM folder, which is where WMI providers are just stored by default. That's cool, but we really need something to use it with. So working with WMI providers is not as difficult as it sounds. For this demo, I created something called Where's My Implant, which is just the DLL that's going to do all the work for the next couple demos. Again, WMI providers are the DLLs that do all the work behind the scenes. These host the methods and properties that we're going to call. So for that Win32_process class, that's hosted within the simwin32.dll. And a very large number of other WMI classes are also hosted in there. So that's a good starting point. And if we're looking at building a provider, what does that take? Well, we have to build it, we have to find a way to register it on the remote system, and then we have to find a way to access it. Now, the process that hosts WMI methods is the WMI PRV SE.exe, and it can host the common language runtime, so we can run .NET applications in there. It's literally as simple to convert a class over to WMI provider as adding the decorators, the management entity, and management tasks for the class and methods respectively. This just is a good template that we use for creating providers. Now, a basic provider that's been done in the past is Jared Atkinson made one called the Evil Net Connection WMI provider to do command line execution, and then Casey Smith made one as a shellcode runner. They both work great. And here's an example of what the output of the PowerShell runner that Jared Atkinson wrote is like. As you can see, it can accept commands over the pipeline. And then here's just another one where we're going to do a PE injection on a remote process. In this case, it's a Metasploit bind payload. But unfortunately, we have to store it somewhere on disk. Primarily, this can be done through a network share. For the sake of simplicity in this demo, just did it just on that disk, which is not ideal. And so we ran that payload and injected it into the remote process, and then executed that remote process thread, which started the bind listener, and we telnetted into it. That's cool, but I feel like we can do better. We talked earlier about being able to store files in WMI. So what we can do is store those files and then extract them in the provider and then inject them. So this works well as a shellcode runner, a DLL injector, and a PE injector. So in this demo, we're going to upload a file to WMI and store it in the provider storage in a static class. We're going to then extract that file from WMI and then reassemble it and then inject it into a process. There we go. Again, this is also the same bind payload that we used earlier. And there we are. In this instance, we injected into the procmon process. But we can do better. So what if we tried to add more power into that? Why not put an Empire stager in our WMI provider? So in this instance, we're going to take a PowerShell payload. We're going to specify the PowerShell payload as being, the Empire payload as being a PowerShell payload, and we're going to specify the server and the staging key. So just going to execute this, and we'll see the callback occur on the Empire server. The one thing to note here is that PowerShell.exe is never called. Again, the WMI PRV SE process is hosting the common language runtime, and we're just running it in a PIC type of situation. So that's cool. But what if we did it slightly differently? Let's rewrite the Empire agent so that it just runs in C#. So we have an embedded Empire agent in there, and we don't need PowerShell anymore. So we don't even need to call the system.management.automation library. And sure enough, if we just specify the .NET for this provider, it'll call back. And as you can see again, we're in that WMI PRV SE process. So you should have a full Empire agent running on this system. That's cool, but providers are useless if you can't register them on the remote system. Historically, .NET providers would need to be installed via install util. You'll see a lot of work coming out of Casey Smith with this binary. The one problem with this is that it triggers in a Windows event log 63, which causes some issues. So again, but we wrapped a command for that to do our remote installs after we write it out to the system. and just using the Win32 process to install. So, but if you look under the surface of what install util does, it's functionally a one-line executable. All it does is call the system.configuration.install.managed installer class and the static and helper method. So what we can do is functionally run install util from PowerShell without calling the install util.exe. The one caveat here is the version of PowerShell version you're using and the .NET assembly need to match. The output is identical to install util. That's cool, but we can do better. There's no reason we can't do a manual registration of our WMI provider through WMI calls. At a high level, what we need to do is create a WMI_extension class on our system, then create an instance in WMI extension for the Win32 implant class. And the Win32 implant class is what we're just naming it arbitrarily this time. Then we'll need to create an instance of _instance provider registration for WMI extension, create an instance of method provider registration for the WMI extension, and then actually create our class, and then register the WMI extension HKey class's root and HKey local machine. If that looks hard, it's because it is. It's awful. But why would we want to do that? Manually registering the provider allows us to bypass calling PowerShell and install util on the remote system. And if you remember those pesky event 63 warnings, that's because the managed installer class installs the provider using the hosting model of local system host. So it runs under the local system context. But there's others. Specifically the network service host, which is hosts Win32 process. So if you want to guess what that hosting model doesn't do, it doesn't trigger that alert. So because it's awful, created a wrapper for it where we just take in the library location and it parses out the library and then installs it as a provider. This takes a little bit longer, so for brevity, that's what the output of that function looks like. And then for blue teamers who are interested in what to look for when installing WMI Providers, here's the Windows event log. And you can see it's pretty detailed. It calls out specifically what the WMI provider is, down to its public key token. So you can find out exactly what's going on there. Any questions? I know that was a lot of information quickly.
The event ID on the last screen.
Sure. That's event ID 63. Sure.
You say when you create a derived class that it might provide password protection. Is there a simple way to check for all classes that derive from the process?
There is. When you open up the class, it'll if you do like get sim class in PowerShell, it'll show you what the parent providers are. It's called the __ superclass,
Yep.
and that'll show you the parent.
Can you do a select from where superclass is?
I believe that that's possible to do. I haven't figured out how to do that query yet. What I would do, in all honesty, was WMI has a debugging log, which fills up very quickly, and because there's a ton of events occurring constantly. But if you alert on certain events, such as the derive and put methods, those will catch the clone classes. Well, I think we're basically out of time. But thank you, everyone. What's that?
Posting your slides?
Yeah. I'll post them on SlideShare. Yep.
See you. Thanks again.
Oh, yeah.
Thanks.
Oh, Discover? Yep.
Okay.
Yep.
See you too.
Yep.
Yeah. That was cool. Of like going to your GitHub and probably gonna use that. I like more of the lateral movement of the process. Create the clone and then just fun stuff rather than them watching the process, which is pretty cool.
Yeah. Yeah. Well, thanks for stopping by. Yeah. Yeah, sure. So we're not utilizing it because I rewrote the in C#. So it's not necessary.
Okay, so it's not using it. But the game using it.
Yeah. It'll still run.
But does it not say reference?
And rename it as best you can.
Well, because we
Use the
rewrote it
format
so it doesn't call PowerShell. So it's PowerShell assembly.
Okay, you guys can publish it.
Yeah, we'll publish that.
Thank you.
Yeah,
That's awesome.
thanks. Thanks.
This actually works.